This is tutorial 3, and now we're going to discuss the stretch and the first step FvFM. At the stretch, you can increase the intensity of your different images. This won't affect the data, but it's only to visualize better images. For example, if I put the color on 10, you will see it like this, but that's a little bit pale. You don't see a lot of it. If you increase it, you will see more and more of the plant, but you also see this occur, the blue lines. This means it's almost oversaturated. So you have to go back a step, for example, for the color. So 40 is quite okay. Here you can see that I checked the steps by 10. We can also increase it by 1 to find the absolute to find the absolute maximum, but you already see at 44. Yeah, like 41 should be the perfect one, 40 would be okay. But this will give you more insight visually. It won't affect the data, but especially if you want to visualize a little bit more. For example, if I go to chlorophyll index, and this is the image, it's completely dark, but you want to see more visual. You can see, like for instance with this, like 35, you can see the lower levels of chlorophyll is in the top leaves. That's quite normal. But now you can see if you lower it bit by bit, you see some spots here. So you can really visually already tell something about the plant. You can see probably there's a little bit of damage here, and that's true because it correlates with the FvFM. So you can see that the chlorophyll is retracting there because of a stress. And in this way you can really make nice images also for papers and stuff like that. If you need a really nice image from chlorophyll index, you can make it yourself and visualize the best result for your paper. Well, we can also do it for the anthocyanin index, so increase it or lower it. 10 is always the minimum. 10 is the level where it was shot on. So if you put everything on 10, it means this is the original level it was shot on. We don't use this as GFP, RFP. But now you can see, for example, NDVI. Let's go to that one. Let me see where it is here. It's pretty pale. And if you want to say, well, I want to increase it a little bit. Okay, we can do that. Increase it by 100 times. And you have a better visual image of the NDVI. So still, it won't affect the data, but it will only visualize a little bit more of the image to make it more prettier, or to visually see the damage better. Here in the bottom part, we can also do different scales for the FvFM color scales. We had some questions about customers. They said, well, this is our own PhenoVation scale, but you can also use different scales, also used by different manufacturers. Or the bottom one, you can also change it up. For us, it doesn't matter that much, but if you want, you can use a different scale to visualize it as you want it. And here in the bottom, we can also zoom into the scale. For instance, I put my PhenoVation scale on it. But if you really want to visualize it a little bit better, you can say, well, I don't want to run the 0 to 1. So 1 means completely green, 0 means black. But if you say 0.8, for example, 0.8, you can see everything is way greener. But you can also see some of the spots here in the bottom. So what I can do now is say, well, why don't we increase this one to 0.2? And then you see all the red spots pop out a little bit better. A little bit more. So this is again to visualize the stress factor a little bit better. So you can make really nice images to show the effect of the stress. This is, of course, one way to do it, but if you want to have it in data, you will do it like this. In the FvFM, you can see we have different classes here, running up to 1. And what we can do here is show classes. And you can see it automatically colors all the different classes. And here on the right side, it will calculate automatically in which class does the pixel, or how many % of the pixels is in a certain class. So you can see the first pixels are in class 3. So that's from 0.32 to 0.48. They're purple. So those are in the middle of this stress. And then you have class 4, that's the yellow one. You can see all the other ones are pretty much yellow, and the green is the healthy part. Again, if you want to change the color, that's possible. So if you say, well, I want all the stresses or everything below 0.64, I want to make it red. Perfect. You make it red, and everything above 0.64 is green. Again, if you want to go back to the original color, press the right mouse button, and it will go back. Delete noise, again, is deleting individual pixels. You can see now we have some black pixels. It means those were individual, and so it's a little bit of noise reduction. So maybe there is noise, and it will take it into account of the measurement. By deleting the noise, you see it will get out of the data set. You can also project the class onto different color images. For example, if I want to class 3, I project it over the color image. You can see it on the color image. So I will stretch the color image a little bit so we can see it a little bit clearer. Class 3, so you can see, oh, there's the disease. Class 4, it's a little bit bigger. And you can also say, do I see the effect in the photosynthesis, for example? Do I visually see it in the color image? Because sometimes you don't. Like in this case, on some spots, you don't see, like here in the bottom probably. Yeah, you don't see the effect. But here you can see it a little bit on color. It's a little bit more darker. But on the photosynthesis, it's clear. Okay, so this is the class of the FvFM. In the next tutorial, I will explain the RGB and also the other indexes because they're pretty much similar. So see you on the next tutorial.